Alright, here we have question 3 of the August 2020 Mathematics Higher Level Paper 1 Khomas Region Matric Mathematics exam. Here we've already looked at question 1 and we've done question 2, nice and short question, and now we're getting to question 3. Yeah, I'm going to do question 3 in the same colors, this is on the same page. And we start off with a small pendulum has a length of 2.449 centimeters. Write this length in kilometers, giving your answer in standard form. Okay, so to go from centimeters to kilometers, let's just write this down. So we've got kilometer, then we've got meter somewhere here, we've got centimeter and millimeter somewhere there. So this is, let's just fold this in decimeter. And this one I think we all know, from kilometers to, or meters to kilometers, that's 1,000. And from meters, these are all tens. So meters to centimeters is 100. So in total, it's 100,000 that we have to move. Again, from centimeters to kilometers, we divide by 100,000. Or we could say, let's say we've got 2 centimeters, so that's the same as 2,0, right? And now we want to move that to kilometers. So what we do is we move it 1, 2, 3, 4, 5 units to the left. So 1, 2, 3, 4, 5. So that's where the comma will now be from here. Moved it 100,000. So we'd actually have this value, right? 0.00002. Okay, so that's exactly what we're going to do here. For standard form, we still need a whole number, a non-zero in front of the decimal. So we're going to write 2.449 times 10. And how far did we move the comma to the left? 5 units. So because it's to the left, we have a negative and 5. That'll give us the number of kilometers. Pretty straightforward. I know sometimes it can be a little bit confusing. Should there be a negative or positive depending on moving left or right? But you should be pretty easily able to see whether it makes sense or not. So if you type this in a calculator, you'll see it's some smallish number, and obviously 2 centimeters or 2.5 centimeters is very few kilometers. So it makes sense that it's a very small number. Okay, question B. The time for one swing of a pendulum of length L meters is t seconds, and t varies as the square root of L. Okay, so t varies as the square root of L. But there could be some constant that we're multiplying with. So that's important to know. If they said it varies inversely with the square root of L, then we would have t varies inversely with the square root of L. So these are your two options. This is just varies or varies directly, and this is varies inversely or indirectly. Okay, so we have this formula. Now we get given some more information in order to be able to find the value of k. So when length is 1.44, okay, so length is 1.44, then we know that the time t is 2.4. Okay, so we can use this to solve for k. So 2.4 is equal to k times square root of 1.44, that should be 1.2. And then we can just divide both sides by 1.2. So these cancel out, and then 2.4 divided by 1.2 is 2. So we know that our k value is 2. Thus we can say our actual equation is t equals 2 times the square root of L, because k is 2 like we just calculated. Now we can use this to solve the rest of the question. So if the time for one swing is 1.8, so we know k is 1.8, equals 2 times, and then we want to find out how long is the pendulum. So we want to solve for L. Okay, I'm going to start off by dividing both sides by 2 here. You could have squared both sides to start with, that would also be fine. So 2 is cancelled out, 1.8 divided by 2 is 0.9, and that's equal to the square root of L. And now in my second step, I'm going to square both sides. So we get L equals 0.9 squared should be 0.81. Let's just make sure about that. 0.9 times 0.9 is in fact 0.81. Okay, and that is our answer for L. Keep on writing an 8 instead of a 0. 0.81 meters. Perfect. Okay, so that'll do it for question 3, and I'll be back shortly with question 4.